Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Data Waves, where this week we're going to talk about using Dremio and DuckDB together, kind of getting the maximum out of both technologies to get the best bang for your buck in your data infrastructure. Okay, talk about how both of them can save you money and simplify your data life, and even better together. But of course, you always want to make sure that you go try out the Lakehouse platform if you haven't. So if you haven't tried out Dremio and gotten hands-on with Dremio, head over to dremio.com/test-drive. Or you can just go to dremio.com and click the little test drive button, and you can try out Dremio at no cost, no obligation. You don't have to create a whole new account. It just allows you to kind of just try it out, take it for a quick spin, so that way you can experience sort of what the big Data Lakehouse story is all about. So try that out at Dremio Test Drive. Also, make sure to pick yourself up a copy of Apache Iceberg, the definitive guide. Okay, so bottom line is what the definitive guide is a book telling you everything you'd want to know about Apache Iceberg and all sort of like the architecture, best practices, all sorts of great stuff. So if you want to get an early copy of that, scan that QR code. New chapters are constantly being released. Full finished copy should be released early 2024. But we have so many great episodes of Gnarly Data Waves coming down the pipeline. Okay, our next episode will be, we'll have an episode on September 6th, but also on September 12th, we're going to have It's Time for an Easier Data Lakehouse, learn what's new in Dremio. And then on September 19th, we're going to have ELT, ETL, and the Dremio Lakehouse, and lots of other really great content on the way. And make sure to stop by and visit Dremio if you're going to be at any of these events like Big Data and AI Paris in September, or Big Data London also in September, or Coalesce by DBT in October. Lots of great events. And again, I will also be able to see you at some events like the Past Data Summit in November, or Big Data Texas in January. So if you're at any of those events, come say hi. And again, today's topic is going to be using Dremio and DuckDB together. And as your speaker for today, it's going to be me. So I will be your chaperone for today, telling you about the awesomeness that is Dremio and DuckDB, and the extra awesomeness they get when they are used together. Okay. Bottom line is, at the end of the day, we're always talking about data architecture and different ways to architect our data infrastructure, and what components should we use, and why should we use them, and how to optimize them. But at the end of the day, what is the goal? Like, what is we trying to do? We want better performance. We want things to be fast. But you can make things fast if you're willing to spend a lot of money. So that's not necessarily the only thing we're optimizing for. We want things to be low cost. Now, you can save yourself a lot of money and not spend a lot, but then things might be really, really slow because you're buying, like, the cheapest compute, with very not necessarily like very resilient architecture. So you might be cheap but break a lot and have poor performance. And you want easy self-usage. Okay, so you can have like a really performant cost optimized infrastructure, but that might be really complicated for your end users to use because there's just so many different knobs and whatnots to get the best of their performance and costs. So you kind of want all these three things, and there's this constant tug of war between the three. And we're constantly trying to figure out, hey, what components, when they fit together, make this all easier. And this is where like Dremio really shines, especially when you're talking about really big data use cases. Okay, so when you're starting against really large scale use cases, you can't really have like a 10 petabyte table sitting on your laptop, okay, being processed by your laptop's processor. Okay, so when you're pulling in lots of data, terabytes, petabytes, Dremio is going to be a great way to process that data because it takes advantage of all parallel processing, because it's a MPP system, a massively parallel processing system for processing queries. But it also helps make it easier to connect all your data, because instead of having to like find different way, run a query here, run a query there, material, then you have to like export this data over here so that way you can load it to over here so you can run it with that data that's over there. You just connect your data to Dremio, connect your databases, connect your data warehouses, connect your data lakes all in one place, and you can query them all together. But again, not only is that processing going to be fast because you're using parallel processing, so multiple computers processing parts of that query at the same time on a Dremio cluster, but you're also using Apache Arrow-based processing, okay, using that columnar in-memory format to really kind of get the best performance possible. on top of other technologies that Dremio uses, such as the C3 columnar cache that allows caching is not only going to improve performance, but also improve costs, because you don't have to run compute as long, and two, you're going to reduce the actual access costs when you're making all those API calls to object storage like S3, because the C3 cache is caching some of those files, so that way it's not having to request them over and over again to S3. And then you have data reflections. That's also going to improve performance, which means cut down costs. Materialized views are something we oftentimes use for performance, but oftentimes it increases your storage costs because your stores are materializations. So reflections takes that approach of having sort of materializations that are used for acceleration, but does them in a way where the materializations are much more reusable and can be tailored in a way to get best performance. So you can actually tailor like their sorting and the partitioning of these reflections, and these reflections can not only be used on the view or table that you've made the reflection on, but any views derived from that view. So you get the best bang for your buck on your materializations. Okay, on top of it, it also can just pretty much supplant the need for many different types of pipelines, because you don't need to make the extra copies, because you can make multiple reflections that are optimized at different dimensions. So that way, different types of queries will just always kind of find sort of the best way to execute. Okay, on top of that, Dremio uses cost-based query optimization and all sorts of other strategies, and has a no-copy workflow. So generally what you do is you connect your data to Dremio and you create logical views on top. So basically, you can alter data types, you can do basically all your last mile ETL work, but you're doing it all through logical views instead of creating, new copies. And then whenever Dremio's performance on a particular logical view needs maybe a little extra boost, that's when you turn on the reflections. You don't always just rush to reflections. But the idea is that Dremio has the performance and has a structure to reduce the need to kind of expand your storage. But then, when you are pushing sort of like those edges of performance, you can turn on reflections and get that extra boost in a very efficient way. But so basically, you see the fast, and we see how it makes it easier by connecting all our data in one place, but it makes it even easier with Dremio semantic layer that allows you to govern the data, so you can control who has access to every individual view, table, source, folder, space. Basically, everything is kind of governable. And then even within the data sets themselves, you can do table and column, row and column masking rules, and so you have really sort of tight-knit control over who has access to what data. But you can organize that data and document it. So you can provide documentation, you can see its lineage. And at the end of the day, is one of your users logs into Dremio, they're only going to see the things you gave them access to. So basically, it creates sort of one place where you can govern all of your data. So basically, you connect your databases, warehouses, lakes. Instead of having to govern the data in each of those realms, you can just sit there and set all those access rules on Dremio. And when people log into Dremio, they only have access to what they have access to. They can read the documentation on it. They can see it well organized, make it super discoverable. And they have easy access to it because they can access it really easy through the web UI, but they can also connect it to their favorite Python script or their favorite BI tool using its ODBC, JDBC interface, REST API, Aeroflight endpoint. Aeroflight is going to be a big topic of today, because it allows for even speedier transport of that data. Because when you transport that data over the Aeroflight endpoint, you're going to end up getting a lot less deserialization, and moving that data. So it's a lot faster because you're keeping it columnar throughout the data transport. Okay, and that's going to allow us to kind of have sort of just that maximum performance. Okay, but bottom line is you can just pull that data to all your data use cases. Okay, so I can have petabytes of data scattered across databases, warehouses, and lakes, bring them into Dremio, and just make them available to everybody, govern them from one place, distribute them in one place for all data use cases, whether that's data applications, BI dashboards, ad hoc analytics, whatever you're trying to do, you can just pull that data right from Dremio. So it just kind of creates this nice layer that kind of unifies and simplifies everything and accelerates it when it needs to. Okay, and then there's DuckDB. DuckDB is an in-process database. Now, what does that mean? If you've used SQLite, you've used an in-process database. Okay, so what does that mean? It means you don't have to run it as a separate process. So if you ever use MySQL or Postgres, generally you have to have a database server running. So there's a separate process that is the database server that generally your Python or your JavaScript or your Java your Java jar communicates with asynchronously. And basically that server is doing the processing of the query and then relaying that data over to your process with your script. The way DuckDB is instead of having the separate process that you communicate with you, it's part of the process that you're running. So it's in process. SQLite's like that. If you ever use SQLite, you can just basically all your code and all the generating of the database, all of this stuff is kind of happening when you use it in your script. Okay, so this makes it kind of really easy to use. It has like no dependencies, so you don't have to worry about any external dependencies. So you can just load it up into whatever language, the DuckDB library for Python or your favorite programming language, and be able to kind of use this sort of in-process database, kind of like SQLite. The big difference is that it's optimized for analytics. So it's columnar, so it stores data in memory in a columnar format, similar to Apache Arrow. Not exactly Apache Arrow, but pretty similar. It uses vectorized query execution, which just that means is that instead of doing everything sort of like one row at a time, you'll have like row batches, and so you have that columnar structure. So you'd be grabbing sort of like the columns of several rows at a time when you're doing processing, allowing you to do faster processing. Okay, it's standalone. Okay, so again, doesn't have any of those other dependencies, and you're allowed to do like asset transactions. It has like all the basic things you'd expect out of a database. But again, it's built to be really fast, especially on sort of like when you're doing like local processing. So this is really, really good for getting the most out of your laptop. Okay. A lot of like the people in the DuckDB camp, they'll talk about how your laptop becomes a data warehouse with DuckDB. And to an extent, your laptop can now process a lot more data than it's ever could before because of DuckDB. Now you're still not going to load up probably a petabyte worth of data on your laptop, but you can probably load up, several gigs, maybe like 100 gigs of data and have that processed by like DuckDB on your laptop, because it doesn't necessarily have to hold all the data in memory for it to process it. It can do that. It can process lots of data pretty quickly. And the beauty of that is the more you can kind of run on your laptop, that doesn't mean you need to spend any cloud compute for those particular queries. So again, that's generally maybe, you have your sales table, which might be several petabytes, because it's sales going since who knows when. So Dremio can handle the query of, let's say, getting the last month of sales. That data is going to come down to your laptop into a DuckDB, and then you can run additional ad hoc analytics from there. With like DuckDB and a Python notebook, and you can do all that additional analytics and using SQL at both ends. So this allows you to kind of really take SQL throughout the entire pipeline. And that's the thing, it's a lot of people feel very comfortable with SQL. Pandas and polars are great data frame libraries that allow you to do really sophisticated analytics. Okay. But again, not everyone feels very comfortable writing a Python script. Okay. So in that case, being able to allow people to use SQL in as many levels of the analytical journey, the better. And this is the great thing about like Dremio, which on the big data space really maximizes how you can use SQL, not just in just analyzing the data, but I mean, when you think of things like Dremio's Arctic catalog, that allows you to do like branching and merging. So it allows you to even do like DevOps data ops pipelines and all sorts of governance all through SQL. So it really maximizes what you can do in SQL. So you can actually really have people like literally doing a good chunk of the data engineering work straight from SQL using Dremio, because basically you just connect the sources of the data, and then basically through SQL you can manage like who has access to it, create users, allocate permissions, ingest data on a branch, create branches, merge branches, and on top of it, all your standard, quick SQL queries to actually run analytics. But then, you generally what happens is that people will pull a portion of the data that they query from Dremio. So again, you might have that multi-petabyte table, and then Dremio's going to crunch that query at the petabyte level. And then you might bring like a handful of gigabytes down to your laptop, and you might bring it into a notebook where you're using Python for pandas and polars. But again, that context switching may not be something that is as accessible to every analyst as SQL can be, and keeping that context in the same. So you bring it down and into what's called a DuckDB relation. You can then, run further SQL on it and really kind of start keeping SQL all the way, kind of like they say jingle all the way at Christmas. It's SQL all the way, because at the end of the day, this is bringing you a Christmas of analytics. Okay. But yeah, So basically, that's one benefit there. But ideally, what you can do, like the simplest way to kind of have these two work together, is to just use Apache Aeroflight, because DuckDB can pretty easily take an Apache Aeroflight table and turn it into a DuckDB table, so that way you can run analytics on it. And then if you use Aeroflight to pull data from Dremio, it's going to already be in that Apache Aero format, which makes it pretty easy to just move it over to DuckDB. To make that even easier, okay, I created a simple library called Dremio Simple Query. What it does, it just kind of abstracts a lot of the setting up of the Aeroflight connection. And so that way it's just really simple and imperative. So basically by using this library, you can quickly pull data from Dremio, almost super easy, really, I mean, super easy. You'll see in a second. And then literally just, continue your local analytics in DuckDB from your laptop. So again, basically allow Dremio to manage and organize the girth of your data. So this way, you're not having to figure out how to pull from 10 different sources on DuckDB and your laptop. You just allow Dremio to coalesce all the data and be the funnel for all your data and all the governance and all that stuff. And then DuckDB can just allow, your analysts to have sort of that extra oomph on their laptops. And it would just look something like this. So in this example query, what I'm doing is I'm basically getting my Dremio token from my environment. Okay. So here I'm just basically getting my environment, this environmental variable called token. And then what I'm doing is I'm getting my arrow endpoint. So Dremio has an arrow endpoint that you would send arrow request to. Okay. And then I'm going to create the Dremio connection. So literally all I have to do is pass it the token and the URI, and done. I'm now connected to Dremio. And in this example, what I'm doing is I'm pulling it down just to show you like how flexible this is. I'm pulling it into pandas. So basically, I can pull down that arrow stream by just doing Dremio to arrow. Okay, so just use that Dremio connection and use this to arrow method and just send it the SQL that I want. Okay, so I'm running this big query on this big data cluster that Dremio has, and it's as simple as that. I just send the SQL right here, Dremio to arrow, and then what I get back is this arrow stream, which I can convert to an arrow table using this function, and then turn that arrow table into a pandas data frame. Okay, so you can see here, like this is a really small script. I now have that data as a pandas data frame, and I can then do all my additional analytics if I prefer like sort of the data frame route. Okay, but again, you can also do this in DuckDB. And again, take a look how straightforward this is. In this Dremio connection object, we have a toDuckDB method. So literally you just run the query you want to send to Dremio, and the data that gets returned gets sent back to you as a DuckDB relation, which you can then use to do additional queries going forward. So you see here, I just say this query method that's on the DuckDB relation you get back, you give a name to the table that's being held in this relation, and then you can run a query against that table. So you see here, select star from table 1, and again, the table 1's coming from there, where field 1 is greater than 1 and field 2 equals label. Okay, so I can run that query right against it. So it makes it, again, pretty easy to keep just doing those additional ad hoc analytics in a notebook. And really kind of, at the end of the day, you would just run it on your laptop and you'll feel like you're doing this, like you're working with like petabytes of data on your laptop, because Dremio is handling the really sort of large scale data set, bringing that lower set, and you're just continuing SQL. Like you're just moving from one SQL statement that's running on Dremio to SQL that's running in DuckDB on your laptop. And what's going to happen is that you're reducing the amount of compute by increasing the amount of compute that occurs on your laptop, reduce the amount of compute that has going on in the cloud. So, but the thing is that it's going to be much easier for your analysts to discover what data sets they have and to govern that data by using Dremio as that central layer in between the two. Okay, so that way, they basically just send their queries to Dremio and they don't have to think about, okay, hey, I'm putting from these files from S3 and then these files from Snowflake, and then I'm going to pull these files from Postgres. All those sources can connect right into Dremio. And then they just have to think about, hey, what query do I need to send to Dremio? They can actually even pre-curate those particular views, so they know, hey, I'm going to get this query from Dremio all the time. They could just create a logical view against all those data sets on Dremio, and they can just do select star from that view, like we did here, and ta-da, they have that data on their laptop, and then they can again continue working from it from DuckDB afterwards. Okay. So again, just kind of giving you that image, what becomes possible is that Dremio becomes sort of this funnel of data. Okay, and you can create all those views, like those joins between these there. So then when the data gets delivered to the analyst who's going to pull it down via Aeroflight into DuckDB, they can just focus on the actual like drilling for insights, because the data curations occurred on the Dremio layer, and the data is already curated, governed, documented, etc. And basically you just have a much simpler sort of process, okay? Because they can again log into the Dremio UI, figure out, hey, what's the view I need, plug that SQL using that Dremio simple query library. Okay. And yeah, so that's pretty much what I'm going to talk about today. So hopefully you guys enjoyed that. My name is Alex Merced. I'm a developer advocate here at Dremio. We're going to open it up for Q&A. If you have questions, I got answers. And I hope, again, I'll see you in the Q&A. So again, if you have any questions, put them in the Q&A box, and I'll be very glad to answer them. So I'm going to start off with the first one. So we got a question from Ganesh. How is this funnel possible if Dremio supports only iceberg files? Well, Dremio doesn't only support iceberg files. Now, basically, the way to put it is Dremio supports many different sources of data. So Dremio as a query engine can support querying from different databases like Postgres and MySQL. You can query actually data warehouses like Redshift and Snowflake, and you can pull data from different table formats, not just Iceberg, but also Delta Lake on the read side. Now, Dremio does have more robust support as far as being able to read and write into Apache Iceberg tables, and is able to natively track Apache Iceberg tables in the Arctic catalog, which allows you to do versioning of those tables. So that way you can do things like multi-table transactions on the Data Lakehouse and whatnot. But Dremio as a query engine supports querying from many sources. So it can act as that funnel because it can reach all those different sources that you connect to Dremio and then submit a query, and then that data gets sent down via Apache Aeroflight to your laptop, in which you can parlay it into a pandas data frame or into a DuckDB relation to do your further ad hoc querying without having to worry about how to coalesce all those different sources of data. Okay, next question from Sujit. Does Dremio support CDC connectors to data sources? Let me think about that. I mean, it depends on sort of like how you're implementing CDC. I think there are some solutions on Dremio software. I'm personally a little bit less familiar with this piece, so probably some of the solution architects can probably give you a little bit more detail what's possible here, because there are a lot of integrations with Dremio with a lot of external tools. But also right now there is native CDC capture in Apache Iceberg, which probably in the future you'll be able to process a lot of those those captures directly in Dremio. But as far as what existing CDC integrations there will probably be in Dremio software. And probably if you sit down with like a Dremio solutions architect, they'll probably kind of go through the different integrations that exist. Are there any resources available for our users to use DuckDB to connect to Dremio in a similar manner? Now, you could just use the Aeroflight libraries that are in R. I'm pretty sure there probably is an Aeroflight library in R, because they exist in like 13 different languages are covered by the Aero project currently. So long as that particular version of the Aero libraries has the Aeroflight connector implementation, you can do so. But the great thing about Apache Aeroflight is that it's done through gRPC, okay? And the beauty of gRPC, it means that, hey, if a particular language doesn't have an existing client, implementing one is actually pretty easy, because you would just take that gRPC framework, and essentially all it is all the details about the actual contract, as far as like, hey, what methods exist and whatnot. They're all built into what's called a proto file. And then basically you would just take the gRPC framework in that language, load up the proto file, and you have a client essentially. And then you pass it the URL to where you're connecting to, and you'd have a out of the box client in that language. So worst case scenario, you could probably implement one pretty quickly with gRPC. The proto file is right there on the Apache Aero framework. More than likely, though, there is a Apache Aero R library, and in that would be the Apache Aeroflight client. Far as like one that kind of abstracts over that layer, like I did with Python, that doesn't exist yet. But if you take a look at my source code, like you can take a look at the source code for Dremio Simple Query, and you'll see that like the actual underlying code isn't too much. So like re-implementing that in any language is you would just follow the same patterns, because the Aero client is going to work the same in any language. It's going to be the same methods. So essentially, you would just replicate my underlying structure in whatever language, and you're done. So it shouldn't be too hard. And again, the code that I wrote in Python for Dremio Simple Query can act as a model to help easily implement that in another language. So that way it's pretty much the same experience. Now, as far as DuckDB libraries in another language to create that simple like DuckDB conversion, that I'm less familiar with what which languages have DuckDB libraries to make use of DuckDB, but I'm pretty sure probably R has something in that regard. But yeah, I would just take a look at the source code for what I wrote in Python, and then just basically mirror that with the Aeroflight implementation in any language that you would like a similar client in. Cool. Any let's see. No, that was the next question. Okay. Oh, okay, great. Thanks. Awesome. Okay, so let me just mark these questions as answered so far. Answered live. So again, Dremio supports all sorts of different file types. So again, connecting to Dremiosonar, the query engine, lots of different types of data you can connect. The iceberg piece is just that when it comes to specifically Dremio's ability to read and write, the write part is specific to iceberg tables. Are there any resources available for our users? Okay, we just talked about that. Again, the actual client is gRPC, and you can use my source code in Python to kind of create it as a model for what to do in other languages. Dremio does DDC port. Again, sit down with the Dremio solutions architect. They'll assess what your needs are and figure out what integrations would best suit your needs. And if there's any additional questions, feel free to put them in the Q&A box. Okay, but otherwise, there's some really cool stuff I'd like to make you guys aware of. So there's some really cool tutorials that we've recently released over there on the Dremio blog at dremio.com/blog, particularly with like Flink. So, I've mentioned DremioArctic a few times. DremioArctic is this catalog service from Dremio that is also powered by a open source project called Nessie. And if you haven't gotten hands-on with Nessie, there's actually a few blogs that we've just released, particularly with like how they use Nessie with Flink. We also have previous blogs where we talk about Nessie with Spark. And then we're going to be having there's some previous, also some articles we talk about using Arctic on Dremio. So there's a lot of resources if you want to kind of like start playing with that. But the cool thing about like the recent Flink one is that it uses a Docker Compose environment. So you can quickly spin this up on your laptop. So you don't have to spin up any cloud infrastructure or pay for anything. You can just try out and see the whole experience end to end right there on your laptop and get more familiar with Flink, get more familiar with Nessie, get more familiar with like the whole idea of like catalog versioning and ingesting data into an Iceberg catalog. So that's a really cool article. And then we have a lot of really other great Dremio and Iceberg and Data Lakehouse content coming up over the next few weeks. So keep checking in here on Gnarly Data Waves every Tuesday. Also, make sure you subscribe to the podcast so you never miss an episode. You can do that on Spotify or iTunes. And also subscribe to the Dremio YouTube channel, youtube.com/Dremio, where actually recently I just dropped a series of hands-on exercises for Iceberg. So if you still haven't spent too much time with Iceberg and just want to see a guided video series of just kind of setting up an environment on your laptop, or writing some Iceberg tables, taking advantage of things like partition evolution and branching and merging, that would be a really great video series to watch. And again, that's at youtube.com/Dremio. But yeah, lots of great content and much more coming on the way. I definitely got a good handful of blogs that are in the pipeline that I think you guys are all going to really like. But otherwise, I'll see you all next week at the same data time at the same data place. This is Alex Brissett from Dremio, signing out of Gnarly Data Waves.